Okay. Everybody can hear me okay? All right. Thanks, everybody, for coming. As mentioned, my name is Rob Shore. I work for Tell Labs. I've actually been at Tell Labs for almost 20 years. I know, I don't look nearly old enough for that, right? Okay, in any case, today we're going to be talking about Tell Labs transport solutions, in particular our approach and our strategies for building next-generation transport networks and the technologies to help enable that. But before that, let's talk a little bit about Tell Labs. For those who don't know the company, Tell Labs has been doing business in Poland for almost 20 years. Traditionally, both in Poland and in EMEA in general, our focus has been mobile backhaul and SDH-based transport. Of course, that takes us back some time. But one of the corporate strategic objectives and strategic focuses has been dynamic optical networking. This is primarily WDM-based ROADM transport networking. And we've been fairly focused on this for the last 5 years. Initially, it was primarily in North America, but for the last few years, we've expanded that focus globally. In fact, we now have over 80 customers worldwide, with 22 of those customers coming in last year alone. And you can see we've started to propagate through EMEA, Asia, and Latin America. We now have over 15 customers in EMEA, and most of those were won last year. Globally, we have over 7,000 platforms deployed for these types of networks. They carry over 900 terabits worth of bandwidth every second, including, by the way, most of NASDAQ's traffic. NASDAQ is now a virtually completely Tell Labs run transport network. Okay? Part of that reason is because of the availability, the traffic reliability you can get not only with our technology, but with these kinds of network design strategies. In fact, most of our customers are achieving almost 7 nines of availability. In fact, we wrote a little white paper on how this is done. Now, this is actually, it's not calculated numbers. This is actually as measured by our customers. In fact, Verizon, who's one of our key customers in North America, keeps very accurate records of these things, and they publish the results. So this is straight from Verizon's measurements, and you can read more about it on the white paper. Okay? Globally speaking, for packet optical transport platforms, Tell Labs is number 2 globally in the industry right now. Okay? And again, a lot of that has been in North America, but as you'll see over the next few years, we're starting to focus more and more globally with these technologies. Okay? As they said, if you have any questions throughout this presentation, please don't hesitate to ask. Okay? Now, with all this experience that we have, we've developed and we've come up with what we believe is the secret for building next-generation transport networks. Now, this will be kind of surprising, but the secret to these networks is the donut. This will answer all your questions. We're going to see as we go through how to build the proper donut-based transport network. And if you're lucky, you might actually get a donut by the end of this session. Okay? But here's the idea. To understand this concept, you have to understand transport networks. First of all, you have to remember, what is the point of a transport network? What is its purpose? And it's pretty straightforward, right? A transport network's job is to transport stuff, right? And that's the whole point of this focus, is stay focused on transporting. Make it efficient, make it simple, right? Better enable service providers to offer services. Make transports easier to operate. And that's part of the whole point of the donut network. Okay? Now, in order to understand how this all comes together, there's a variety of parts of a transport network. It's important to understand the different components of a transport network. There's the access, which connects the user, the cell tower, the residence, the business to your network. Then there's what we call the metro or regional network, which is a single city or maybe a small region within a country. Then we have the core networks, which interconnect major cities for a medium-sized core network within a single country, or the large core networks, which would include a pan-European network interconnecting countries, or for big countries like Russia or the United States or China that might be big enough to be a whole continent by themselves. Okay? So again, that's the different parts of the transport network. Okay, so now we have to start looking at trends, right? The donut strategy is based on certain networking trends. Now, I'm glad you're all sitting down because this next piece is going to be very shocking, okay? No other vendor here, no other presenter has given you this information, okay? It's very surprising, but Tellabs has done a lot of research and determined that bandwidth is growing. I know, it's crazy. It's true. Okay, obviously we all know this, right? Bandwidth is growing. It's growing very steeply. Obviously, there's a lot of factors driving that. But the question isn't, is bandwidth growing? The question is, what does that mean, right? What does that mean in particular to a transport network? Okay? Well, if you take a look at it, and these are just some statistics of individual users' bandwidth, and you can see in Poland alone, you've got about 47% year-over-year growth in consumer bandwidth consumption. So, I mean, individual users' bandwidth is going way up. What that means essentially, right, is that each one of these little, I'll call them serving wire centers, right? Each one of these little end offices that's serving, in many cases, a variety of customers, business, residential, mobile, they could require a full 10 gig worth of bandwidth. If you add all the video and the internet, some of the cloud-based services, right? The idea is the result of this bandwidth growing is it's changing the kind of requirements you have near the edge of the network. Okay? So that's kind of point number one. That's the first realization to understanding the donut. Okay? So you've got this concept of each end office potentially requiring a 10 gig, either now or in the near future. The next big shift in transport networking is what I call the ROADM effect. ROADMs have been around for a while, but there's this very steep cost curve for ROADMs. ROADM costs are coming down very significantly, and not just the ROADM itself, but all the components around it. The power balancing, the amplification, the monitoring, all of these things are becoming more integrated and much more accessible in many more networks. Okay? So what does that do for you? What do ROADMs provide? Well, the main benefit of a ROADM is it enables you to optically express traffic so that services coming into a system can be sent through that system easily, seamlessly, and extremely cost-effectively. Right? In fact, just some quick numbers. The average cost to optically express a signal through a system is about 200 euros. That's for an entire wavelength. 10 gig, 40 gig, 100 gig, it doesn't matter. Right? That's the cost to optically express, compared to the cost to terminate to a router or a switch or something, could run you as much as 6,000 euros. Right? What this tells us is, really, once you make a wavelength in a network, you want to keep it a wavelength as much as possible. The more you can keep a signal optical, the dramatically cheaper it will be for you to transport that. Now, you couple this fact with ROADMs coming down in price, the cost of optical express being so low, with the performance of current optical technologies. You now have basically off-the-shelf optical components, right, and technologies that can run you almost 15 or 1,500 kilometers unregenerated. That means I could put a single card here and another card way over here. I could pass through as many as 16 or 17 locations completely optically, 1,500 kilometers with just 2 cards. So you've got the ability now to have very low-cost optical express and the ability to reach virtually anything. And what it does is it caused this curve for cost of transport now. You used to have this fairly steep cost per distance. The further you went, the more expensive it became. But that cost now, with this ROADM-based networks, that cost curve has come way down. ROADMs are now accessible in most parts of the network, and the cost to transport through that kind of network is very, very cheap. In fact, it's virtually negligible. Right? When doing the costs of a network, the cost of transiting of optical express is barely worth considering. It's so cheap. So what it's done effectively is it's made distance not really a factor anymore in transport networks. So the idea behind this is when you're deciding where to put critical resources in the network, this completely changes your options. In the past, you would distribute everything. The closer you could get to the customer with your critical resource, a router, a server, a cloud, whatever, the better, because the less transport you would have to do. The problem is that distributing your resources costs money. You have to buy multiple copies of each one of those devices. If you have some kind of video storage device, right, you have to buy multiple copies of that. Each one has to have storage, massive storage capacity. And the whole point of it has been to eliminate the cost of transporting from the center. But now that transport essentially doesn't cost anything, what it enables service providers to do is to start centralizing these resources. Now notice, this doesn't necessarily mean eliminate resource. You see the little animation took the critical resource, the router or storage device, and just moved it to a centralized location. Right? We'll talk about the benefits this provides in a little bit, but the idea is now this is an option for service providers because the cost of going from here to here I'll point. The cost of going from here to here is virtually the same as going from here to here. There is no economic value to distribute this stuff anymore. On top of that, because the distance from here to here can be as much as 1,500 kilometers, you can actually take this core part of the network and actually shift it closer and closer to the center. So now, instead of having 20 core locations and 200 access or aggregation locations, you can have only core locations, and you can have about 8 instead of 20. And now the parts that used to be here can be relocated here, and you can have fewer of them. So the idea here is that these things are an option now. We'll talk about the value of them in a moment, but the idea is this dynamic optical networking, this very cost-effective ROADM-based networks, give you this option to put your critical resources anywhere you want, irrespective of distance. Does that make sense so far? We can talk about the actual numbers offline here, but again, this is the premise. Okay? Now, having said that, there's another critical aspect of these transport networks. Okay? Yes, ROADMs helped eliminate distance, but there's another factor that have to be considered in terms of improving efficiency of these networks. One of the big problems, okay, is the circuit-based transport technologies. Right? Everybody knows SDH, right? Okay. Does everybody know OTN? Okay. Does everybody recognize the fact that OTN is essentially a larger version of SDH? Okay. They're basically the same thing. They're circuit-based transport mechanisms that provide point-to-point transport. The problem with both of them is that when you're trying to deliver services from some kind of service edge, so you've got your data center here or the internet or whatever, when you have multiple destinations to deliver to, because the transport box, the OTN or SDH transport device, does not have the ability to steer packet traffic, all it can do is take traffic that comes in on one port, put it in a box, and send it all to the same place. What it means is that you need a separate physical handoff from each of the service edges for each destination. If I have 50 destinations to send traffic to, I will need 50 separate physical handoffs from my service edge. Right? Even if I decided to put some kind of router or switch in between to aggregate, I would need 50 physical handoffs from that device to the transport. Right? And I need that for every single service edge. Then even when I get out to the edge of my network, because I have these separate physical interfaces for each different service type, I need something to aggregate that and hand it to my DSLAMs or business customers or switches to go to the cell towers. Right? And this is the problem with circuit-based transport. One other interesting fact. Not only do I need separate physical handoffs, but each physical handoff has to be of a size based on the maximum potential utilization for that location. If each of the 50 locations had a maximum usage of a gig-E, I would need 50 separate physical gig-E's for my service edge. Does that make sense? Okay. Introduce packet optical networks. Right? By integrating some layer 2 functionality into your transport platform, it enables you now to have aggregated handoffs from your service edge. And the transport platform can now break them up and aggregate them and send an aggregated stream to the end office. Right? And then at the same time, at the end office, it can break them up and hand them off to the subtended devices. Now, not only, of course, do I get the aggregated handoff, but I can also statistically multiplex. If I needed 50 gig-E's based on maximum utilization, maybe it's only 20 gig based on average utilization. So instead of 5 10 gigs, I could do it with 2. Right? So this is the whole benefit of packet optical. Does that make sense? Any questions on that piece? All right. Everybody still awake, right? All right. Okay. So that's the concept, right? So you have these two separate concepts. You have this ability now to essentially locate critical resources anywhere. You could put them in a very centralized location. You have this packet optical platform that can take very large single handoffs from the service edge, 10 gig, 40 gig, 100 gig, and then distribute them and aggregate them and statistically multiplex them to single destinations. Right? And this is where the whole vision starts coming together for us. Right? Essentially, you've got some metro regions. These are individual cities. These are perhaps regional networks interconnecting 5, 10 cities. And then, of course, you have core networks interconnecting countries or in the entire countries or even international. But the whole idea, right, is you take these distributed resources, you deploy these dynamic optical technologies, and you can relocate those resources in a more centralized location. Right? Then, of course, because distance means nothing, you can take those locations and combine them into fewer core locations. Right? That doesn't mean one for the country, but you can take, we did a big study with Telecom Italia that took their 20 regions that they have in their country in Italy, and we broke it down to 3. They could solve it in 3 regions, which means 6 core locations. Each region has redundant core locations. And this is the network that they're now moving towards. Right? So that's the idea. And remember, this doesn't mean eliminating anything necessarily. Right? So people that like the hierarchical router structure, you can keep that. It's just instead of putting one router here and another router here, you just put them both in the same place. Now, this does also have one other important advantage. One problem with distributed resources is you don't get to use them all effectively. If I have a router here and a router here, and this router exhausts, but this router still has 90% available capacity, I can't use that router to serve these guys. I have to put in a second router, even though I had a lot of extra capacity on that one. But by centralizing them, I can use every critical resource to its maximum potential before buying the next one. Okay? And this is the idea. And then, of course, at the edge, now this is where you have options. You can integrate a layer 2 function at the edge, or you can keep this as an edge router, a layer 3 device at the edge. You have your choice. The router is going to be more expensive, right, but probably offer a little bit more functionality. Okay? So that's the idea at the edge. But in the core, you've got this optical express all the way back to a core location, and a packet optical device here to distribute traffic to all the destinations. That's essentially the whole concept. So again, if you sum it up here, you've got the centralized resources, oh, by the way, one other interesting thing is by having fewer and larger core locations, it will enable you to generate more traffic from each one and have fewer of them. It makes it very easy to just do very simple, basic 100 gig point-to-point transport between your hub locations, your core locations. When you have 20 or 30 core locations, it makes a good case for OTN, because you have to send a pipe and drop some off and pass the rest through. Okay? But this essentially eliminates the need for OTN in your core part of your network. Because you only have a few locations, you can create a complete mesh between 8 locations with just point-to-point 100 gig transport. Very basic, very cost-effective transport from your core locations. So that's what you do. You have the centralized core locations, very dense with all your resources. You've got basic transparent transport through the core. You have integrated layer 2 grooming here to take big handoffs from the service edge and steer them towards the end. And then pure optical express all the way to the end. Then, of course, you have the option of integrating layer 2 at the edge or having a layer 3 device. Again, there's definitely pluses and minuses to each. Okay? One thing about, even if you decide to put layer 3 at the edge, there's still a lot of traffic that you definitely do not want going through a router. For example, if you sell a point-to-point transparent 10 gig service, you clearly don't want that going through a router. And there's good arguments to make about Ethernet private line services and even Ethernet virtual private line services not going through routers. Okay? Again, there's arguments both sides, but it doesn't really matter to the vision. Right? You have the option of either way. Are there any questions on any of this stuff? Okay. Now, so here's the benefits. So this is what you can do and what we're proposing. But let's go over the benefits of this stuff again. So, of course, the number one benefit is the more, and I mentioned this on the last slide, the more efficient use of critical resources. By putting them all at one place, or a few places in the network, you have visibility to the entire network. You can completely use the capacity of a resource before buying the next one, because I can connect any one of these edge locations to my core resources. Okay? Number two, of course, is you minimize resource waste. If I put a router at the edge, or in an aggregation location, and traffic transits that router, that's a waste, right? That has no value. Transit traffic through a router has virtually no value, because it's just going to hit another router upstream. So any traffic I send through is wasted. This, for us, now has no waste of that nature, because there is no, oh, look at that. It's time to do a backup. Talk about cloud computing. We actually use a cloud-based service for our network backups. Okay. In any case, so you eliminate that waste of transiting traffic through routers. Okay. Then the next piece, of course, is it reduces troubleshooting. Now, this is really interesting. This is part of the way we get to 6 nines, or almost 7 nines. By having your critical resources in one location, you eliminate what we call multi-layer troubleshooting. Once the traffic arrives here, my two routers, my aggregation router, my service router, they're right next to each other. You have all the resources right there. It's not router, transport, router, and then the router guys are saying it's the transport fault, and the transport saying it's the router's fault. Right? You don't have that issue anymore. They're both in one location, which also makes it easier to troubleshoot because you can see physically both devices. And one other thing. Now, this isn't statistical, it's just logical. You talk to service providers, and you ask them if all of their troubleshooting staff, if all of their resources are equally skilled, right? Of course not. You have some people are more skilled and some people are less skilled. Well, where are the most skilled people? Well, you put them at your critical locations in the core. If you have router devices out here, there's usually less skilled people that are out there. So what might take a skilled person an hour to troubleshoot might take a less skilled person 3 hours to troubleshoot, forgetting about the fact that they have to constantly be calling back and forth between the locations to figure out what's going on. So not only is everything in one location, but those locations have all your most skilled people. Verizon, again, did a study on this. By moving to this type of architecture, they reduced troubleshooting time across all services by 30%. Took them about 3 years to deploy the infrastructure and get it complete, but once they did that, their troubleshooting went down by 30%. Right? And again, it's because of this. It just makes troubleshooting easier. Now, on top of that, there's a variety of things that Tell Labs has built onto the optical layer to make monitoring and management of the optical signals much more effective. Okay? Again, if you want details, you can feel free to swing by our booth, and we can give you more details on that. But this is the idea. So the next piece, of course, is you accelerate service activation. Why? Because now when you want to turn up a service, if it's a point-to-point transparent service, that's one card, Optical Express, 2 cards. Again, back to Verizon. Verizon now has a guaranteed SLA service activation of 2 hours for any service to any points in their network. Right? A 2-hour service activation time. Because again, there's nothing to it. Even if you're going back to a cloud-based service or an IPVPN or whatever, it's still many less interfaces. I'm not now touching this office, offices in between, and the core office. I'm only going to 2 places, here, and everything else is Optical Express for every service that I offer. Yes? 5 minutes. All right, 2 more slides. I'm going to be fine. Okay. So that's the whole concept, right? You can very easily turn up services because there's less locations that need physical interaction. Of course, there's another aspect of improved reliability beyond reducing troubleshooting time. You ask people, what is one of the primary causes of failure in a network? What would you say? It's people. People are one of the primary causes. Provisioning things wrong, or even connecting things wrong. What this does is it says when you need to turn up a service, I touch here and I touch here. Everything in between, there are 0 additional physical connections that need to be made. No dirty fibers, no plugging things in the wrong port, no plugging things in this port and then knocking the fibers off of that port. There's just nothing to touch in the middle of your network. Again, it's another primary way in which our customers have achieved almost 7 nines of availability for their service because they dramatically reduced the number of human-induced traffic outages. And then, of course, finally, the overall operational costs in general, where you have faster service activation, your operational cost for activating that service is much lower. When you have faster troubleshooting, so all of this stuff ties together to create a very, very small operational expense, right? Operational envelope. Okay? This is essentially the whole concept. So if we review, in the 2 minutes I have remaining, this is essentially how you make a transport donut. You start with some type of intelligent aggregation at the edge. Could be layer 2 or layer 3. You have Optical Express all the way back to a very centralized core location. Then you interconnect a minimum number of core locations with transparent 100 gig transport, or even higher when it's available. And this is your donut. Make sense? Okay. Now, Tell Labs in particular, of course, our whole portfolio, our transport portfolio, is designed around this vision, right? To make a very low-cost, flexible optical layer. We have a variety of patented techniques in which you can manage that optical layer and deploy that optical layer cost-effectively, all the way down to some very cost-effective packet-oriented access devices, and all the way to very, very large core transport systems. Okay? Again, any information about the donut, or if you want a donut, feel free to come by Tell Labs booth. We can tell you more about the technologies, more about the vision, and answer any other questions that you might have. And that essentially is it. And it's the whole concept, of course, is what we call dynamic optical networking, with a logo we largely stole from Pink Floyd's Dark Side of the Moon, if anybody knows that album. Okay. Any questions before we wrap up? I have about 30 seconds, so you have to speak quickly. Yes?
I have one question. Because kind of
Yes.
You said that you are working with Telecom Italia or any other carriers. My question is, did you went through all the services they have, the legacy services, and map them into this new concept?
Yeah, we did, for Telecom Italia in particular, we did an extremely exhaustive 6-month study with them where they analyzed, and they gave us great study information because they gave us every office, real data, and every single service type, but not just what most service providers do and say a gig E from here to here. Okay? They said, you know, DSL traffic was this peak, this minimum, this average. You know, mobile traffic, 5 cell towers connected to this location with this peak, this minimum, this average, this mix of traffic. So they gave us that complete information for the entire Milan region. So we did that study 6 months. And by the way, this is information we'd be happy to go over with people. Telecom Italia has given us authority to share that data with others, right, in a general sense. So yeah, it does. The reason why it's in opposition to others, first of all, a lot of other people pushing network visions sell routers. Their job is to sell as many as they can. Distributed architecture sells more routers. It just does. The other factor is that most of these router vendors and most of these visions have been built based on roughly 3 to 4 year old information about the cost of transport. Literally in the last 24 months, the cost of this stuff has come way down. For example, Tel Labs now has an entire ROADM degree, including input amplifier, output amplifier, the ROADM card, the spectrum analyzer, the supervisory channel, the interleaver, everything on a single card. Just one card with everything, right? And of course, that drives the costs way down. So 5 years ago, you had to distribute because transport was expensive. That's not true anymore. The ROADMs, the curve of ROADMs have completely turned things upside down.
I see it still being expensive.
Well, I'll be happy to go over it with you. I mean, again, really, I think it'll surprise you if you start looking at these networks at how cost-effectively you can deploy this kind of dynamic optical infrastructure. So we'll be happy to take that skepticism on at our booth. Any other questions? All right. I'm more or less right on time. All right. Thank you.